In this video, I would like to demonstrate the strategies of doing word questions. In class, as a matter of fact, we tried this question. And you can see all these questions, you don't need to use algebra, but using algebra would tremendously help you to have a very simple, straightforward, concise, as well as a very elegant solution to these type of word questions. Now, for example, this one, it says, Ellie is 6 years old and her dad is 37. How long would it be before her dad is twice as old as she is? So we pursue this question without, I deliberately said without using algebra. So then we just use our common sense. So then Ellie is represented by E. Dad is just represented by D. Okay, now Ellie now is 6 years old. The dad is 37. Now from now, next year, Ellie will be 7. Dad will be 38. And then she will be 8. And then will be 39. Oh, this is pretty tedious. Oh my gosh. Like, I'm just going to write. And then you can see Ellie is going to catch up onto Dad. Closer. At a certain point, Dad's age will be twice as old as Ellie. So then some students says, well, why don't I just add on another 10 years? Sure, 10 years. And then she's 18. And the dad is 10 years, 49. The 49 double 18? No, not really. Okay, well then should we add on another 20 years? But then another 10 years? But some students says, well, you know, right from the beginning, in between is 31. So why don't we, this one add on 31? So like, really, does that make any sense to add on 31? But hey, we can say, so then that's 38. And then that is 68. So, but you just try it. So then this one, if I add on another 10 years, and then this will be 28, and then this will be 59. Oh, okay, well, not really. Okay, well then from here, kind of like getting closer. So then why don't we say, okay, 29. Okay, so then the 60. Oh, still not. And then 30. And that is 30, 61. And then, okay, 31, 62. Oh, bingo. All right, so now, so then how many years now? Okay, 1, 2, 3. So that's 3 years here. And then there's another 10 years, 13 years. And then there's another 10 years, another 10 years. And then 1, 2, 3. Okay, so it's 1, 2, 3, 1, 2, so it's 25 years. Then 25 become 31, 37, add on 25, become 62. So with this kind of common sense to approach this question is perfectly fine. However, if using algebra, it will be much simpler. Now, for example, so twice as old as she is, that's one condition. How long will it be? So basically, doing this type of question, first of all, is a translation. Translation of a language into a mathematical language. All right. Now, another thing is that we are going to use so-called using algebra means we're going to set up X. Set up and a variable, and then we solve for it, and then we get our answer. So set up a variable. What's going on with my pen? Okay. So set up a variable also, this also means, as far as I'm concerned, whatever the question it is, then that's your variable. So how long, that means how long is my variable. So let X be how long. Whatever it is a question, it is your variable. So let X be how long, right? So now the Alice, so this word, as a matter of fact, you see the translation? This how long, it is already erased. So I already translated this. And then Ali is 6, our dad is 37. So Ali is 6. Now Ali plus how long, that will be Ali's age. And then the dad age will be 37 plus X, right? So that also means this Ali 6, dad 37. This already reflect over here. And will be, so that's why a plus X, will plus X. Now that is twice, so that means if I multiply by 2 here, now this age and this age should be equal. And then that's my equation. So then I already finished my equation. And this time I just going to solve my equation. It's a very easy task for all of you now. So then that is that equals to 37 plus X. Now move this one over here. It becomes X now. Move this one over there. It becomes 25. And then we're done. Okay. So let me demonstrate another question here. Okay, so now let's take a look at this one. So one number is 14. I'm going to use a different color. So one number is 14, greater than another number. When the smaller number is subtracted from the twice the large number, the difference is 97. So basically, then find each number. So find each number. Each number will be my variables. Now in this case, I wanted to have the smaller number. Let smaller number be X. Let the S be smaller number. So this is a smaller number. And then I would let the L be the larger number. So then this already done. So this is the question always translated into my variables. Now next, one number is 14 greater than another number. So that means X, the smaller number, add on to 14, that will give me my large number. So then this sentence, finish translation, cross it out. Now, when smaller number is subtracted from twice the large number, oh my gosh, twice of the large number, so twice of the large number. Now subtract twice of the large number, subtract from twice of the large number, subtract the smaller number, and then that is 97, right? The difference is 97. So that's this sentence is my equation. And then I finish this one. So you see, every single word in this English paragraph, now it is this mathematical language here. This is absolutely just a translation, all right? Now here, let's talk about how we're going to solve this, because there's got a smaller number and got a bigger number. So then that means the larger number is this much smaller number. So why don't I bring this larger number into here? Therefore, then I would have only one variable to solve. So in this case, 2 larger number is substituted by S plus 14. And then subtract S. Now that equals to 97. So then in this case, multiply this in, and that is 2S plus 28. Subtract S, this is not 5, all right, equals to 97. Okay, now this becomes just S. Then move the 28 to the other side. So it's 97, subtract 28. Now therefore my S equals to, how much is this? 69. All right, so if my S is 69, and therefore my L is plus 14, and then that gave me 83. right? Then that's my solution. Okay. Now, as the conclusion, now doing this kind of word questions that we used to say, nowadays I'm not that, very rigid with this type of question anymore. However, before, we are always talking about the 4 steps. Now, the first step is to set up the variable. But you see, after you finish 4 steps, you basically not only finish translation, you also finished the whole solution. So first of all, set up a variable means a let sentence. Let x be. Let x be what? Be the thing you're looking for, right? Be the thing that whatever, find the number and let x be the number. Find the number, let x be the number. Find the number, let x be the number. Find the number, let x be the number. Find the 3 angles. Yes, let x be one of the angles, and then all the other ones is related to this one angle, right? How long? Let x be this how long. So we kind of got this, hopefully you kind of got this taste about what let x be means. All right. Now the second one is just to write the equation. Now write the equation means keep translation. Write the equation. Because whatever says this, the result, then that means it's equal. The result that is equal, right? Okay, how long would it be or twice as old as she is? All these things will give you an equal sign. So then you write the equation, and the third one is to solve the equation. So that means you find your answer, solve, and the first one is to always say use a complete sentence as a final answer. Complete sentence. So this one we will be doing a more practice to see how do we do the 4 steps. Okay. Now this question is very important. I would like all of you to try first before I demonstrate. You should be able to figure this out. Thank you for watching.